All right, let's get right into it. We are going to unpack three new, and I mean really new, protocols that are basically set to change the entire game for how AI agents talk to each other and work together. Seriously, if you are building anything with AI right now, you absolutely need to know this stuff.
Just think about that for a second. I mean, really, what if every single specialized AI agent, I don't care who made it, what company, what system it's running on, what if they could all just talk, delegate tasks, share info, and solve huge problems together? Well, that's the future we're talking about today.
But that's not where we are. Not yet. Right now, most agents are living in their own little digital worlds. They're incredibly powerful, sure, but they're isolated. They can't communicate. They can't collaborate. And that right there is the big problem we need to solve.
So here's the plan. First, we'll talk about why agents need to talk. Then we'll break down the three big protocols you need to know: MCP, A2A, and ACP. After that, we'll see how they all fit together. And finally, we'll take a peek at what the future might look like. Sound good? Let's go. You see, for AI to hit that next level, agents have to have a common language. It's kind of like the early internet, right? Computers couldn't do much together until we got a shared protocol, good old TCP/IP, that let them all communicate. AI agents are basically at that exact same point right now. And these protocols, well, they're the new TCP/IP. So let's kick things off with our first protocol, MCP. Honestly, the best way to think about MCP is like it's a universal power adapter for your AI. It lets an agent plug into literally any data source or any tool, no matter what kind of weird plug it has. Okay, so what is it officially? The Model Context Protocol, or MCP, comes to us from Anthropic. And its whole job, its entire reason for being, is to create one standard way to feed LLMs structured, real-time information from the outside world. It's all about connecting that brain in a jar to all the useful stuff out there.
So, how does it actually pull this off? Well, it really boils down to three key things. First, it injects context, by grabbing outside info from files or APIs. Second, it does what's called function routing, which is just a fancy way of saying it lets the model use external tools like searching a database in real time. And third, it orchestrates prompts, building them on the fly with only the info that's needed. This is huge because it keeps the model super lean but also incredibly powerful.
All right, so MCP connects an agent to tools. Got it. But what about connecting an agent to another agent? Well, for that, we need our second protocol, A2A. For this one, think of a universal translator at the UN. It lets agents from different countries or, different companies understand each other perfectly. This one, A2A, comes from Google, and its focus is all about what they call horizontal interoperability. It's not about hooking into a database. It's about letting all these different agents, built by totally different people, talk and work together across the web. So how does that work? The secret sauce here is something called an agent card, and it's exactly what it sounds like. It's a business card for an AI. It's a simple little file that says, "Hi, I'm this agent, here's what I'm good at, and here's how you can ask me to do something." This simple idea is what lets agents find each other and start working together, all on their own. Okay, so we've connected agents to tools with MCP, and we've connected them to other agents across the internet with A2A. But what if you need them to talk super fast, locally, maybe without even being connected to the internet? That's where our third protocol, ACP, comes into the picture. This one is like a set of walkie-talkies for a team on a very specific mission. ACP, which comes from BAI and IBM, is all about local-first communication. So unlike A2A and MCP, which are built for the cloud, ACP is designed for agents that are running on the same device or the same local network. It's built for speed and efficiency.
And this is exactly where ACP is the star of the show. It's perfect for things that need to be fast, like robotics, where every millisecond is critical. It's also the go-to for anything privacy-focused, where you need to keep all the data offline. Or think about places like a factory floor that might not even have a solid internet connection. ACP is built for that.
So now we've got these three different protocols. You might be thinking, okay, so which one is going to win? But that's the wrong question. They're not competing at all. The big thing to understand here is that they're designed to solve totally different problems, and they actually work together incredibly well. Let's just boil it down. MCP's job? It's the plug. It gives an AI agent access to the whole wide world of data and tools. Simple as that. And A2A's job? It's the language. It lets that same agent team up and collaborate with other agents. You put them together, and suddenly you have a powerful, smart, and connected system. And this table just lays it all out perfectly. You've got MCP from Anthropic, focused on tools,
A2A from Google, focused on connecting agents over the web, and ACP for agents that need to talk in a local environment. See? Each one has its own job, its own sweet spot.
So these protocols are starting to get some serious traction. What does that mean for the future? Well, the road ahead could really go in a few different directions.
The best case scenario, we get convergence. Everything just works together beautifully, right out of the box. The worst case, fragmentation. Every big company pushes its own proprietary version, and we end up right back where we started, with a mess of standards that don't talk to each other. But there's a very likely middle ground. Open source tools, middleware, that act as translators, giving developers one clean way to interact with all of them.
And that really leaves us with the million-dollar question. The choices we all make right now, how we build on these standards, how we adopt them, that's what's going to decide what happens next. Are we going to build a truly open, collaborative AI ecosystem, or are we just building a shinier, more sophisticated set of silos?
Look, this is just the tip of the iceberg. The whole world of agentic AI is moving at a breakneck pace, and just understanding these protocols is only one piece of a much larger puzzle. Things like AI architecture, product strategy, that's where you really start to see who's leading the pack. This is where the real work begins. And hey, if you really want to stay on the bleeding edge of this stuff, a fantastic resource is the AI Product Management Playbook by Deepak over on LinkedIn. It's basically where all the VPs and product managers who are actually building this future are sharing their playbooks on agentic AI. It's a great place to continue the conversation we started here today.